So let me put down what she said. So motion is said to have taken place if there is a change in the position of a body. Excellent. But Nana Kwentua, can't we describe motion to have taken place if there is a change in speed, the speed or velocity of a body?
Yes, please.
Why? Why can't we say that?
So please, we can say that.
You think we can describe motion to have taken place if there's a change in speed? Okay.
Yes.
So motion is said to have taken place if there's a change in the position of a body. Please, the body here refers to you and I. The body here refers to cars. The body here refers to anything that can move. Is that okay? So
Yes.
in physics, when we use a body, that is what we mean. Anything that can actually move from one point to another. So that is it. To say that motion to have taken place, in fact, you cannot claim to be moving if you are standing at one place. If you claim to be moving, then we expect that your position changes. So that is motion. Okay, motion is said to have taken place if there is a change in the position of a body. Now let's come back to our main point. What is linear motion? Linear motion. Any idea? We are joining two words, linear and then motion. We've understood what motion is. So what is linear motion? Any idea? Just please, this is a democratic class. You can just express what you think with us. Okay, I have Samsung A1. Just so I go ahead.
Please,
Oh, Kaswa,
in a straight line.
Your line was actually dropping. Can you come again?
Sir, please, I think it is the change of
Okay, that's what. Well taken. Elikem, your hand is up. All right, Elikem, go ahead.
Please, linear motion is when the change. Linear motion is the change in the position of a body along a.
Okay, so a change in the position of a body along a straight line. Perfect. That's good. Janelle, your hand was raised earlier. Let's hear from Janelle for the last time, then I come in. Janelle, you can come in.
Linear motion refers to the movement of an object in the.
So, thank you. The movement of a body along a straight line is what linear motion is. So, the motion of a body or a particle in a straight line is what linear motion is. In physics, we have a lot of motions we'll be considering. One of it is what we are currently discussing, linear motion. We also have the motion of a body in a circular path, circular motion. We also have the motion of a body along a fixed point, the repeated up and down or to and fro motion of a body along a fixed point, which is simple or oscillatory motion. Then we have projectile motion. In fact, we have a lot of motions we'll be looking at. Okay, we have a lot of motions we'll be looking at. So our first kind of motion which we are considering is linear. Now, in discussing linear motion, there are key terms we also need to understand and then apply. One of it is distance. We have to understand what distance is. Then we will go through or look at another dimension, displacement. Then we look at speed. We'll also look at velocity. Then acceleration. So these are the key terms we are going to consider under linear motion. Class, what do we mean by the term distance? Or how would you explain a distance? What is a distance? So these are the key terms. The key terms are what we are considering. What is a distance? In fact, we've all been witnesses of athletics in our various JHS, even in secondary school. Okay, we have long distance events, short distance, 100 meters. What is a distance? How would you explain the term a distance to a brother? Anybody? Frank, or say, I'm sure you are 100 meters runner. Frank.
Distance refers to the total area covered by a body.
So Frank is saying that distance is the total area covered by a body. Frank, thanks for the contribution. Ablina?
The distance is a measurement of how far apart objects are.
How far apart objects
Objects.
are. Thank you. Finally, Elikem, what is your version of distance?
This distance is the amount of space between two objects.
Thank you. So all the contributions clearly relate to the concept distance. Okay. In a simple term, I'll say that distance is the interval between 2 points. Okay, which is no different from all the contributions shared. Okay, so distance is the interval between 2 points, but I'll qualify it a little bit in a straight line so that it matches our linear motion in a straight line. So a point A, a point B. If I draw a line to join the 2 points. Okay, if I draw a line to join the 2 points, the interval between point A and point B is a distance. And this interval is in a straight line. So simply, distance is the interval between 2 points. Okay, in a straight line. So at Cape Coast can be a one locus or location. Another point which can be Accra. Another, okay, we have another point. When we join Cape Coast, the point Cape Coast to the point Accra, the interval between Cape Coast to Accra gives us the distance from Cape Coast to Accra or Accra to Cape Coast. Are you okay? Please, when you come in, mute yourself for us. What do you think is the SI unit of distance? What is the SI unit of distance? Yes, Alikem.
Meter.
Meter. Or the SI unit for distance is the meter. Thank you. So a distance can be a very long distance or short distance. So long as what we are considering is just the interval between 2 points, it's a distance. So length, height, length, height, radius, diameter. So long as all these can be looked at as the distance between 2 points, they are all distance. So length is a distance. The length of a book is a distance between maybe the vertices or the ends of the book. Your height is a distance from your toe to your to your skull. Okay, the interval between is a distance. Radius of a circle is a distance. Diameter of a circle or diameter is also a distance. So understand the fact that a distance can be long and can equally be short. Is that okay? Now, the SI unit is a meter, and SI unit is a universally accepted unit. Okay, so the unit meter, when you move from Accra to Ankara in Turkey, it is used. When you move from Peking in Ghana to Peking in China, it is used. If you move from Brekum in Ghana to Beijing in China, it is used. So SI units are universally accepted units of measurement. So for distance, its accepted unit is the length. Now, if the SI unit for measuring distance is meter, where from other units such as centimeter, millimeter, decimeter, nanometer, and so on and so forth. So class, the question is that if the SI unit for distance, measuring distance or length is the meter, where from centimeter and millimeter? Yes, what is it? Anyone to share something with us? Where from centimeter, millimeter, and those other units? Anybody? Frank, can you share what you think about this with us?
No idea on that.
Elikem. Elikem. Okay. Once there is absolute silence, then I must actually drink from the cup. See, depending on the magnitude of the distance in question, apart from even, we have what we also call as kilometer. Okay, so we use these subunits depending on the magnitude of the distance involved. So for long distances from Cape Coast to Accra, Tema to Accra, we use the unit kilo. We express the meters in kilo. Okay, and what is kilo? 1 kilometer is equivalent to 1,000 meter. And let me estimate 1 meter. 1 meter, I'm sure you've seen meter rules in your labs before. Class, have you seen meter rules from your laboratories before? A meter rule.
Yes, sir.
Good. So imagine the size or the magnitude of your meter rule. It means that for 1 kilometer, 1,000 of such lengths, okay, would give you 1 kilometer. So we said that 1 kilometer is equivalent to 1,000 meter. Then other units, such as the centimeter. Centimeter is a subunit of a meter. And one meter is actually equivalent to 100 centimeter. So if you've taken time to look at your meter rule very well, you realize that the 1 meter is divided into 100 subunits. And those subunits are the centimeter. Okay, so it runs from 1 centimeter up to 100 centimeter, meaning that 1 meter is equivalent to 100 centimeter. Okay, then we have the millimeter. Millimeter. The same 1 meter is also equivalent to 1,000 millimeter, meaning that the 1 meter rule, when we want to express it in millimeters, must be divided into 1,000. So 1 meter equals 1,000 millimeter, and so 1 meter is equal to 1,000 millimeter, and then 1 centimeter is also equivalent to 10 millimeter. So this subunit depends on whatever we want to measure, depending on the magnitude of, okay, whatever we want to measure. But the universally accepted unit is actually the meter. And that also explains the reason why, you see, in all the units considered, there is meter. So subdivisions of that. When we come to measurements, I'll throw more light on this, for better clarification. Please, is there any question? All right, then let's look at the other quantity, which is displacement. Displacement. So displacement. What is displacement? Any idea? Okay, Kasua.
He said it is how out far out of place.
Okay, Kasua, thank you. Frank, Okay. Frank, are you
The
ready? Mhm.
yes,
Go
the
ahead.
initial and final the this one distance between the initial and final destination during motion.
Okay, let's hear from Hassana.
Sir, please. Displacement is the change in position of an object.
The change in position of an object. Okay, thank you. All contributions, yes, actually have something to do with displacement. Now, 2 points A, another point B. The body, the interval between the 2 points, this is the distance. Now, the body can either move from a point A to B or from the point B to A. Let's assume that this distance is 10 meters. When we represent this by the numerical value 10 meters, we are actually describing the distance covered by the body. But if we want to indicate how the body moved in covering the distance 10 meters, we must indicate a direction. So Kasua moved from a point A to a point B. Here we are actually clarifying how Kasua moved. So the nature of her movement is being described. And this describing how Kasua moved gives it a direction of motion. She moved from A to B. Frank can also decide to move from, Frank moved from a point B to a point A and covered a distance of 10 meters, meaning that the distance between point A and B is 10 meters. But I'm also describing how Frank moved, how Frank's position changed from B to A. He moved from B to A. Okay. So here I'm not only talking about the magnitude of Kasua Frank's movement, but I'm also including how he or she moved. So I'm adding direction. So whenever we are describing distance covered and also indicate the direction, it changes from just distance to displacement. So we define displacement as distance covered in a specified, the distance covered in a specified direction. So if I want to include how Frank moved, maybe Frank moved from A to B, then I must indicate an arrow in the middle of this line to indicate that Frank moved from point A to B. So this 10 meter with an arrow indicating a movement from A to B is what describes displacement. So displacement is distance covered, the distance, Motorola, I'll come to you. The distance covered in a specified in a specified direction. Yes, Motorola, come in. Hello, Motorola. I'm sure you wanted to ask a question. All right. Okay. So if the order of movement, I want to indicate the order of movement, but this time, maybe our dear Motorola moved from B, the point B to A, then this is how I'll indicate the direction. The same distance covered, 10 meters. Agosia, you are writing on my board. Clean it. All right. So displacement is the distance covered in a specified direction. Any question? How important is the displacement? Imagine you want to direct somebody to your house. Maybe you met the person at the station, and the person wants you to direct him or her to your house. You can't just say that, oh, my house is 500 meters from here. To say 500 meters where? You must include direction. So maybe move from the station or from this very point, move a distance of 500 meters north, 500 meters south, or east or west. And by adding this, you are including direction. So direction, displacement enables us to identify the bearing or precise location. Please, is that okay? However, during athletics, we don't need directions to distances to cover. Maybe you want to cover compete in 100 meters. All that you need is the distance called 100 meters. Whether the 100 meters is at the north or east, or you don't care. All that you want to prove your competency in running. And so you just need 100 meters to beat your competitors. Okay. So when it comes to bearings or locations, then we need displacement and not just giving us distances. All right. Now, the next thing we want to look at is speed. Speed. I think you did this in science, JHS science, and then mathematics. What is speed? What do we mean by speed? Yes, Frank.
Speed is the distance covered in a specific time frame.
So the distance covered within a specified time frame. Okay. Yes. So we can calculate for speed, the speed of a body by taking the ratio of the distance covered by the time taken. By the time taken to cover. So distance covered divided by the time taken. Now, when a body covers a distance within a shorter time, and another body covers the same distance within a longer time, which one would have a lesser, which one would have a greater speed? A body A covers a distance within a shorter time. Another body covers the same distance within a longer time. Which one which one will be moving at a greater speed? Frank.
The one covered in a shorter time.
Okay, so yes, that's true. So before it said Usain Bolt, I don't know if somebody has beaten his record. Usain Bolt could cover 100 meters within 9.63 seconds. Usain Bolt then was covering 100 meters within a time of 9.63 seconds. Okay. And so he was declared the fastest person in the world because no other person was able to cover the same distance with this time. And so whenever we talk about speed, speed is the distance covered within a given time, and a body covering a particular distance within a lesser time, okay, has a greater speed than another body covering the same distance within a larger time. Now, let's look at velocity. And how does velocity changes, how does it vary? Or how different is velocity from speed? What is velocity? What is velocity? Jacob.
Sir, please, velocity is the vector quantity that describes the rate of change of an object's position with respect to time.
Come again.
Velocity is a vector quantity that describes the rate of change of an object's position with respect to time.
All right, thank you. So when Jacob was giving us his version of velocity, he was talking about change in the position of a body with respect to time. Okay, and that's the change in position of a body with respect to time describes displacement. So speed is distance over time, whereas velocity is the rate of change of displacement with respect to time. The rate of change of displacement with respect to time. Whereas speed, as said earlier, is the rate of change of distance with respect to time. Okay, so distance relates to speed, whereas displacement relates to velocity. So V is change in displacement over time interval. Whereas this one is also change in distance over time interval. The time interval. Now the SI unit of this speed, distance is measured in, the SI unit of distance is the meter. The SI unit of time is second. So the SI unit of speed is actually meter per second. Let's look at SI unit of velocity. change in displacement. Change in displacement, even though the distance within a specified direction, okay, the unit of the distance is still in meter. We in determining the unit, we do not look at the direction. So meter per time interval, SI unit, second. So speed, velocity also has its unit as meter per second. So both quantities, speed and velocity, have the same unit, just as distance and displacement also have the same unit. Class, is that okay?
Yes, please.
All right. Okay, then please, if you have any question, feel free to ask, okay? The next quantity of interest. And before we look at it, let me draw your attention to, you see, meter per second is the SI unit, but you can be given a question in other units. Maybe distance, instead of it being in meter, will be given to you in centimeter. Time can be given to you in an hour, in a day, and all that. So you must learn how to convert. In converting distances, I told you, I've given you the equivalent, that 1 kilometer is equal to or equivalent to 1,000 meter, and 1 meter is equivalent to 100 centimeter. Then 1 centimeter is also equivalent to 10 millimeter, and 1 meter also equivalent to 1,000 millimeter. So please note this conversions or equivalence carefully. I'll be giving problems where there will be the need of you to use them. Then for time, we know 60 seconds. 60 seconds is equivalent to what? Class, 60 seconds is equivalent to
1 minute.
1 minute.
1 minute. Then 60 minutes is equivalent to
1 hour.
1 hour.
1 hour. Then 3,600 seconds is also equivalent to
1 hour.
1 hour. So note this carefully, because I'll be giving you problems and would even give you the time in days and weeks and even months, and we shall see where the power lies. Is that okay? All right. So our next area to look at is acceleration. In fact, we actually accelerating in what we are doing. Acceleration and rather deceleration. So acceleration of a body. So we are still looking at linear motion, a body moving in a straight line. What is acceleration? Any idea? Frank? Frank, I've called you.
Acceleration is the rate of change of velocity with respect to time.
Okay. Jacob, what do you also have to say? All right. So, Elikem.
Acceleration is the increase in speed of a body.
All right. No, not bad. So, just as contributors said, when we talk about acceleration, is the rate at which the speed or velocity of a body changes with respect to time. Okay, so the rate of change of speed or velocity with respect to time is acceleration. Now, when a body is moving and there is no change in its direction, okay, when a body is moving and there is no change in its direction, in fact, the speed of a body is equal to, is the same as the velocity. Okay, so acceleration is actually delta V over T. In fact, so where delta V equals change in velocity or speed, and T is time interval. So please, T is not just a time, but there must be the interval between two time. So we can actually also define T as delta T, because fine, you understand it very well when we start solving problems with when we start answering questions. So for acceleration, change, there must be a change in the velocity of the body, and note that the change in velocity can be an increased velocity, or instead of using an increasing velocity or decreasing velocity. Example, if you are to move a car from your homes, okay, you start the car and then move gradually because you can't speed up from your house. You move the car, and don't forget the car initially was stationary, wasn't moving. So when the car is stationary, its velocity is 0. Then you moved it gradually, navigating to get a straight path. So you move the car. Whilst you move it, you are increasing the speed. Then when you get a straight road where traffic isn't much, then you speed. So you started from when the speed of the car or velocity was 0, then was increased a little bit, moved it slowly from one point, then you increased the speed, you accelerated. So here we see an increasing speed with respect to time, and we describe the body to be accelerating. So when a body accelerates, its speed increases with time. You were moving at a top speed. At a point, you felt you need to stop. So you decrease your speed gradually to a point where you finally come to a stop. What are you doing? Here you are decreasing your speed with time. So if you have a decreasing speed with respect to time, this is known as deceleration. Deceleration or retardation. So acceleration has to do with increasing speed with time, whereas deceleration or retardation also has to do with decreasing speed. Decreasing speed or velocity with time. Class, are we fine?
Yes, please.
So we often say that deceleration is the negative of acceleration. Okay, so fine. You when we start solving questions, you understand better. I want you to help me determine the SI unit of acceleration or deceleration. Change in velocity over time. Yes. Anybody to help? Nana, when you are help out.
Please, the SI unit for acceleration is meter per second squared.
Okay, she's saying meter per second squared. So let's derive it together. Velocity has a unit as meter per second. Then the time interval is also in second. So we have meter per second, giving us meter per second squared. Okay, so this is acceleration. The SI unit of acceleration is meter per second squared, meaning that it can also be in centimeter per second squared for you to convert, kilometer per hour squared. Okay, or even meter per minute squared, so that you convert to SI units. Then deceleration, you see, because acceleration is about increasing velocity from 0, 1, 2 to any higher value. This is for acceleration. For deceleration, deceleration, we must start from a higher value, then drop it to lesser value. So from a higher value to 1, then if the body is coming to a stop, 0. Okay, so look at the reason why deceleration is negative is that for acceleration, if I want to find a change in velocity, the change is always the final velocity minus the initial velocity. Okay, now look at our final value. In the example I stated, our final value is the question mark, the higher value, minus the initial velocity is 0. So when we divide this by time, the numerator will be positive because we are subtracting 0 from a higher value. So positive divided by positive is always positive. Now look at deceleration. So the deceleration will also be final velocity minus initial velocity all over time interval. Here, our final velocity is 0. Initial velocity, the higher unknown velocity, divided by the time interval. So, 0, subtracting a higher value from 0 will certainly give you a negative. So that is why we deceleration is considered to be negative, whereas acceleration is considered positive. Class, is that understood?
Yes, please.
Yes, please.
Any question?
No, please.
All right.
No, please.
All right. The next thing I want us to look at is graphs of motion. Graph of motion. This motion exhibited by a body can be plotted on a graph. Graph of motion. Now, in plotting graphs, we have the independent variable and then the dependent variable. We have independent variable and the dependent. The independent variable is always taken as the x-axis. So the independent variable is always the x-axis. And then the dependent variable is always along the, it's taken as the y-axis. So in equation of a straight line, the y is equal to mx plus c. So if you are to plot this on a graph, because any change in x would affect y, it means that y depends on x. So the independent variable, okay, you see, the x values would give you a corresponding y value. So if I give you the linear equation, y is equal to 2x plus 2. And then to find y, I must give you x values. So when x is 0, when x is 1, when x is 2, 3, you can use this to find the corresponding y value. So when x is 0, what is the value of y? Quick, quick. When x is 0, what is the value of y?
2.
That is 2. When x is 1, y will be
4.
When x is 2,
6.
when x is 3. So y depends on x. And so in graphing this, y is taken as a vertical axis, whereas x, which does not depend on y, is taken as a, is that okay? So in plotting graphs, we always, the x-axis is always the independent variable, whereas the y-axis is the dependent variable. And when we plot this, it must give us a straight line where there's picking any 2 points on the straight line. So changing y over the change in x will give you the slope. So delta y over delta x. And for my equation, the slope is equal to m. The slope is the gradient, and in the mathematical equation, the gradient or the slope is represented by the letter m. What is c? What does the c here represent? Okay, your Jacob.
Sir, please, the C is a constant.
Constant, yes, but what does it also mean? Explain further. Anybody? Jacob has shared with us what he thinks. So let me have more views. Why C represents the... Your math teacher will beat you. Okay, so the C represents where the graph cuts the vertical axis. Okay, so where the graph, the straight line cuts the vertical axis is what we are representing as C. So assuming you draw a graph and the graph cuts the vertical axis as, say, maybe 2. It means your C is equal to 2. Okay, so C is the intercept on the vertical, axis. Vertical axis. So you read it from actually the point where your graph cuts the y-axis. Is it understood?
Yes.
All right. Please give me some time. I want to take shots of attendance and upload. So just a minute will do, right?
Okay.
All right. So back from commercial break. Okay, so that's it. Now, in plotting in graphs of motion, you see, time is an independent variable or quantity. Time doesn't care about you. You must care about using time. That is why 2024 is gone and will never come back. But the question is, what did you use the time 2024 for? So it's as if time even does not know you and I. But we are given about 70 years as the Bible and then the Quran says. So how are you using your 70 years on earth? So time is an independent variable. You depend on the time. So in plotting in graphs of motion, the independent variable is always the time. We plot these quantities against time, which is an independent variable. Please, is it clear?
Yes, sir.
Yes, please.
Yes, sir.
So it's a graph of time on the horizontal axis, and then maybe yes, you are given some distances in a particular direction to cover, or a distance. So we are looking at how you are going to cover this distance within a given time. So 100 meters. 1 second, how much will you cover? 2, 3, 4, 5. So if you are so fast as myself, okay, maybe I can cover 100 meters within 9 seconds. I may beat Usain Bolt's record. What about you? Okay, so in this case, we are plotting displacement or distance against time. Place in kinematics. And that is what we are doing. Mathematical treatment to motion. What we are discussing is on kinematics. Mathematical treatment to motion. Displacement is represented by the letter small s. So if you see small s slash the unit, it means this under kinematics or linear motion, this represents displacement. Okay, this represents displacement. Now, when the distance covered increases with as time goes by, 1 second, how much are you covering? 2, 3, 4, 5. How much? Okay, or what is the magnitude of distance covered? When you plot such motion, you have a straight line, either starting from the origin or having an intercept. So this is for increasing distance in a specified direction. So when the distance covered in a particular direction increases, okay, the graph plotted, or the graph will look like this. So let me give you a table example. So table of value. So this is time, seconds, maybe starting from 0, 1, 2, 3, 4. So we have time interval of 1 second. And then the distance covered within that direction, maybe 2, 4, 6, 8, 10, in that uniform order. Okay. So when you plot such motion, at time t is equal to 0, the distance covered, okay, so here must be 0. It must be 0. So 0, 2, 4, 6, 8. At time t is equal to 0, distance covered 0. At time t is equal to 2 seconds. So 4, 6, 8. This is, oh, the time is up to, I took it as the velocity, the distance rather. So I should have maintained this rather. This is 0, 2, 4, 6, 8. And this is 1, 2, 3, 4. Of course, this is 0, 0, the point 0, 0. And we have 2, 4, 6, and this is 8. So at time 0, 0, this is it. Our time is equal to 1 second. The distance covered is 2. So this will be somewhere here. Our time t is equal to 2 seconds. Distance covered 4. This will be here. T is equal to 3 seconds. Distance covered 6. Four seconds, distance covered 8. So when you join the point, you must have a straight line. Can you help me determine the slope of this? Help me determine the slope or the gradient. And in determining the slope, you can pick any 2 points. I am choosing this point and then this point. So my slope S is equal to changing displacement over the change in time. What's the change in displacement? The maximum displacement 8. Then the minimum displacement, this is actually delta S. And this is delta T. So if I want my maximum displacement, I must read it from here. Okay, so my maximum is 8. Minimum is equal to 2. Class, I hope you are following.
Yeah.
My time, maximum time 4. Minimum time is 1. Therefore, my slope is equal to 6 over 3, which is equal to 2. You see, the reason why we include the units is that we can also use this to find the unit of our final work. So meter per second. Now, if I should pick any different 2 points for the slope, maybe this one and this one, change in the vertical, change in the horizontal, the slope must give me the same value. What is the maximum? This is 6 minus the minimum y value 4. Maximum time 3, minimum time 2. So 2 over 1 meter per second. So once you have a straight line, no matter the point considered, you must get the same value. And because of this, if you have this motion is known as uniform velocity motion. Uniform velocity motion. So in a uniform velocity motion, the rate of change of displacement, okay, with respect to time is equal to a constant. Listen to the definition of uniform velocity motion. Uniform velocity motion. In a uniform velocity motion, the rate of change of displacement with respect to time is equal to a constant. The rate of change of displacement with respect to time is a constant, or is constant. Is constant. Why is it termed uniform? It is uniform because, you see, in finding the slope, no matter the 2 points taken, you are getting the same value. The same value, 2, no matter the 2 points. Okay, so we are getting same value. Why is it termed velocity? Velocity because under this motion, the slope of a displacement time graph is equal to the velocity. So when we calculated, we got 2 meters per second. Meter per second means that it is the unit for velocity or speed. So this is the reason why this motion is termed uniform velocity motion. Uniform because the value of velocity is the same along the straight line. Velocity because under displacement time graph, okay, the slope is equal to the velocity of the body. Okay, so things to derive from a displacement time graph. 1, for a displacement time graph, displacement dash time graph, the slope or gradient is equal to the velocity. Okay, so that is one key thing you can identify under a velocity time graph. The slope is equal to the displacement, a displacement time graph. The slope is equal to the velocity of the body. Plus, we can also have a situation where, you see, in the first point considered, we had this displacement increasing with time. Okay, we had this the displacement increasing with respect to time. So look at our table. The time increases in that order, whereas in equal intervals, whereas the speed also increases in that equal interval. We can also have a situation where the displacement decreases with time in that equal order. For the same table, but this time we are looking at how the displacement decreases with time. I hope you are not tired. Don't be tired because I'm not tired. Okay. So 0, 1, 2, 3, 4, 5. Then this is displacement. 0, 2, 4, 6, 8, 10. And when you plot such a graph, the horizontal axis is always the independent variable time. The vertical axis is displacement, the dependent variable. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 2 up to 10. Let's even do it up to 8 in order not to be different from the first one. So 2, 4, 6, 8. Okay. So when you plot, of course, when we plot, we must get a straight line. So let's just draw a straight line. Just as we had. Okay. Now, no, I think before. Let me clear undo. You see, let's plot this. At time t is equal to 0, displacement is 0. So the point will be here. At time t is equal to 1 second, displacement is 2. Hello, hold on. This time around, you see, I told you we are looking at decreasing, that the distance covered is decreasing with time. So it must actually start from 10. Earlier, the distance was increasing as time increases, but this time the body's distance covered is decreasing. So at time t is equal to 0, the body is at the maximum distance covered, 10. Okay, when time is 1 second, the body has decreased its distance covered in that direction by 2. So 8, 6, 4, 2, then 0. So it means that the body is now coming back to its starting place. Earlier, it was going this way. So this was the graph moving in that direction. It's starting from time 0, distance 0 to a distance of 10. Now let's plot this one. At t is equal to 0, the distance covered is 10. So the body is here at t is equal to 0. At t is equal to 1 second, the distance covered is 8. The body is here. T is equal to 2, 6. The distance covered now is 6. T is equal to 3. Distance covered 4. T is equal to 4. Distance covered 2. Then t is equal to 5. Distance covered 0. When you join this point, oh, my point, you should join it well. Okay. So before, the graph was just like this. And so it is as if now the body got to its maximum distance. Maybe you move to 100 meters and it is returning to where its origin, returning to where it started, its origin, by this graph. Class, do we understand it? Are we okay?
Yes, please.
Yes, sir.
Good. So if you find this slope, you still have negative. You get a negative of the same value. Let's pick 2 points. This point and then this point. So change in the vertical, change in the horizontal. Delta S, delta T. So slope is equal to delta change in S over change in T. What is the final T value? Displacement value. The final displacement, okay, at this point is 2. I pick at time 1 second and 4 seconds. Don't forget, time is always increasing. So when time is 1, this is the displacement. So when time increases to 4, this is the final displacement. So final displacement 2 minus initial displacement 8 divided by the time interval 4 minus 1, which is 3. So we have negative 6 on 3, which is still negative 2 meters per second. Just as, okay, so this is also known as uniform velocity motion. By here, the velocity is decreasing, or the body is returning to its starting point, where the body is, okay, returning to its starting point. So please, under displacement time graph, the slope of a displacement time graph is equal to the speed or velocity of the body. So this is equal to the velocity or speed. Okay, and this is for uniform velocity motion, where the displacement of the body increases in equal intervals with equal time. Any question? All right. Another, please, is there any question? Okay. Let's also look at another kind of graph where we are going to plot velocity against time. Before I do that, let me ask something. We've just seen that if you have a graph of motion, displacement time graph, and whenever we have a straight line, this is for uniform velocity motion. Okay, where the rate of change of velocity with respect to time is constant. Can somebody tell me what this graph also means? If you have a graph like this, displacement against time. But this time, class, the graph is just a straight horizontal line. What does this graph actually mean? What does it mean? Then let me draw. Okay, Frank. Frank, go ahead.
Does it mean the slope is 0?
Yes, the slope is 0. Gerard, Stop writing on the board. Erase it. It is my board, not your board. Frank, the slope is 0.
Yes, please.
And what does it mean if the slope is 0? Okay, Nana, when you are.
Please, when the slope is 0, it means that the body is at rest.
Yes, can you explain further? Gideon, you're also writing. Can somebody explain? She's saying that it means that the body is at rest. Okay, Ablina, your hand is up.
Please, there is no charge in distance.
There's no change.
Change in distance, sorry.
It is true. That is true. Okay, thank you for. Okay, Kasua. Last
Please.
contribution.
The velocity.
Hey, Kasua's network. That's why your line is breaking.
Please, there is no velocity.
No velocity. Yes, once the slope, don't forget the slope of a velocity displacement time graph would give us the velocity. So if the slope is 0, it means 0 velocity. Thank you as well. Okay, so you see, this is a graph of a stationary body. Example, during your inter-schools, Kasua claims to be good in 400 meters, 800 input. So when the whistle went, Kasua moved some distance and then got here. Maybe Kasua covered a distance of 800 meters, and Kasua covered 100. Then, as time increases, Kasua, who claimed to be very good in 800 meters, is just resting at where she got to. Okay, you went 100. Time also increases. So 2, 4, 6, 8, 10, 12, 14. Time continues to increase, but Kasua is found at the same place she initially managed to move to. So it means that you are stationary. Okay, from 0, you move. When it starts, you were able to, but after 2 seconds, you were at the same location. For after another 2 seconds, you are at the same place. So it means that when you have a displacement time graph and the gradient or the slope is 0, it means the body is stationary. Stationary or at rest. So this is a graph of a stationary body. So when the slope is 0, the velocity of the body or the speed of the body is 0. And when you are a body and your speed is 0, then it means you are not moving. You are not even walking. Please, class, are you okay?
Yes, sir.
Now this one too. As time increases, we realize that the distance covered is also increasing. Okay, so as time increases, the distance covered is also increasing. Now, this is also a graph of an increasing distance or distance in a specified direction with time. But the graph is curvy because the change in displacement is not in equal intervals. Look at this one. After every 1 second. So 10, 8, 6, 4, 2. So the change in distance in that direction is in equal intervals. Here is is not in equal intervals, not in equal intervals or interval. Okay, so we call this motion as non-uniform velocity motion. Non-uniform velocity motion. Non-uniform because the distance covered doesn't change in equal intervals. Distance covered is not in equal intervals. That is why it is said to be non-uniform. Now, under such motion, because it's a curve, you cannot find the slope for all the plotted points. You can't do that as we did in this case or in this case. Okay? But you can only find slope within a given time. Maybe in a time t, what you do is that you can only find the slope within this given time. Draw a tangent to the curve. There's a tangent. A tangent is a line which just touches the side of a curve and is perpendicular to the radius. You get there. When you get there, you will enjoy. So you draw a tangent and then find the change in the vertical, change in the horizontal within a given set of time. So we are finding this within maybe a time 4 seconds. So the slope of a non-uniform velocity motion is known as you can only find what we call instantaneous velocity. The word instantaneous means that within a given time, instant. Okay, so you can only find the velocity of the body within a given time. Within a given time. Please, are you okay?
Yes, sir.
So for a non-uniform velocity motion, you can only determine the instantaneous velocity, meaning velocity within a given time. Velocity within a given time. We'll solve, I'll give examples so we solve it from Thursday. And that would entrench your understanding. Okay. So you can only determine the instantaneous velocity, meaning velocity within a given time. All right. Please ask questions. So, okay, let's move on to velocity time graph. Velocity time graph. We've done displacement time graph. So velocity time graph. In a velocity or speed time graph, we are plotting the velocity of a body against time. Still, time is an independent variable. Time doesn't care about what Usain Bolt is doing with it. Usain Bolt must rather care about what to do within a given time. I'm this time adding aesthetics to my drawing. Mhm. And I'm sure you should also add statics to your drawing. Add beauty, okay? Mhm. So horizontal axis time, vertical axis velocity, or let me give a tabular situation. A body is moving such that, oh, in fact, I need to add aesthetics to my drawing. A body is moving such that the body's speed increases in equal intervals with time. So 1, 2, 3, 4, 5. Oh, 5. Okay, so this is time, and then this is velocity in meter per second. So 0, 1, 2, 3, 4, 5. At time t is equal to 0, the speed of the body or the velocity is 0, 5, 10, 15, 20, 25. When we plot, this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then the velocity, this is 5, 10, 15, 20, 25. So let's plot our values. At time t is equal to 0, velocity 0. At time t is equal to 1, velocity 5. This is 10. 15. 20. 25. So when you join these points, let's join the plotted point. You have a straight line. Okay. Okay, class, help me find the slope. Help me determine the slope. Let me pick any 2 points for you. This one. And then this one. Delta V in meter per second against delta T in second. So find a slope for me. For me, Alithia, Akosia, Enima, let's roll call whilst you work on Didier, Elikem, Frank, Gideon, Asana, Global, Nokia, HMD, Global Nokia, Isaac Newton, Jacob, Jaila, Alika, are you true? Manuela,
Yes,
okay. What's the gradient?
the slope is 5
Anybody else?
meters per second.
Are you sure? Watch again, oh. Frank, say. Frank, what did you get as a slope?
5 meter per second square.
The unit is very important, so let's confirm. Change in vertical, this is 25 minus 5 over 5 minus 1. So 20 on 4. Okay. And so this is 5
Say,
meter per second squared.
hello.
Hello, Gideon.
Say, please, what's the difference between the distance time, the displacement time graph and the
Velocity time graph.
yes?
So Gideon, you see the displacement time graph, we are plotting the distance covered by the body in a particular direction against time. Then here we are plotting the speed or the velocity of the body, okay, against time. Are you okay? So if a body is accelerating, when the body is stationary, the velocity of the body is 0. When the body begins to walk, the velocity or the speed is not 0. When the body begins to run, the speed is increasing. So this is what we are doing. We are plotting the changing speed of the body against the time taken. So at time 0 seconds, the speed of the body is 0. When time is 1 second, the speed of the body is 5 meters per second. When the time increases to 2, it is 10. So we have increasing speed against time. So in velocity time graph, we are plotting the velocity or the speed of the body against time. Whereas in displacement time graph, it is the distance covered or by the body within a particular direction plotted against time. Gideon, are you okay? Gideon, are you okay? Gideon is gone. Okay, so let's pick this 2 points as well. Find the slope. Do that for me quickly. We are taking different points. This one and then this one. Help me find the slope. And what is the result? We have 5 minutes to end the lesson, so let's be quick. What's the second slope? Yes, Akosia.
5 meters per second square.
The same value. So 20 minus 10.
Yes, please.
All right. Divided by 4 minus 2. So 10 over 2, which is also 5 meters per second squared. If I should even pick this 2, the value is the same. 20 minus 15 divided by 4 minus 3, 5. So we realize that when you have a motion such that the body's speed increases in equal intervals against equal time intervals, the body has a uniform slope. Okay, and so this motion is termed as, because the slope is equal to the acceleration of the body, the slope is equal to acceleration. Look at the unit, meter per second squared. We term this as uniform accelerated motion. Uniform accelerated motion. So in a uniform accelerated motion, the rate of change of acceleration is constant. In a uniformly accelerated motion, the rate of change of acceleration is constant. Or you can define a uniform accelerated motion as the motion of a body whose speed or velocity increases whose velocity increases in equal intervals within equal time interval. So the velocity increases in equal interval within equal time interval. Somebody should help me before we end. So please, we have 2 minutes. What do you think the slope of a velocity time graph would give us? What would the slope of a velocity time graph give us? Yes. Frank.
The acceleration.
Good. So the slope of a velocity time graph is equal to the acceleration. Whereas the slope of this displacement time graph is equal to what? The slope of a displacement time is equal to, yeah, Frank?
The velocity.
The velocity. Now, if the graph is like this, what does it mean? Class, if your graph has a zero gradient or slope like this, if your velocity time graph has this, what does it mean? Frank, Frank, let me call somebody else. Hold on. Another hand is up. Let me call him or her. Yes, go ahead if your hand is up. Oh, okay. Emelda.
Yes, please. It means the body is stationary or it's at rest.
Emelda, I won't buy this. I won't buy it at all. Elikam, what does this graph actually mean? What does it mean? Elikam is quiet too. Okay, yes, Frank, what do you think? We are signing out. So, Frank, what does it mean?
It is in a constant velocity.
The velocity is constant or the speed is constant. If it's maybe 10, time can increase to whatever. The value is still the same. So under velocity time graph, if you have the slope or the gradient to be 0, it means the velocity, the body is moving with a constant velocity. Constant velocity. So class is exactly 12 o'clock. And this is where I think we'll draw the curtains on today's meeting. I think it's been exciting having everyone around. Okay. Yeah, this is Mr. Adria. This is me. So we'll continue our meeting on Thursday. Okay. Thanks so much for your time, your contribution, and everything. We'll definitely meet again on Thursday. But please do revise. I'll put some questions together this evening so that you try your hands at them in order to entrench your understanding. Until Thursday, may the good Lord be with you, take care of you, and help you out in your understanding. Take care and bye-bye.
Bye.
Bye.